This is a Rock Island train in the all-blue scheme of Rock Island before they went bankrupt and were liquidated by the courts in their final liquidation in April 1980, I believe. These are USA Trains gp38s, where I mounted KD907s and datum precision coupler boxes. They're CNC machined metal coupler boxes. They have the proper coupler height, and I also raised these locos about 94 thousandths of an inch to bring them into more realistic railhead height. The train has 18 total cars, including the caboose. There are 10 Aristocraft 100-ton hoppers here, which are fairly realistic. And all the cars have KD center set couplers, mostly 906 types, or the engine in the caboose, of course, has the couplers from the 907 assembly. And they're all center set couplers, of course. And there are also 4 Aristocraft covered 70-ton covered hoppers that I had lowered about 2/10 of an inch, or 220 thousandths, somewhere in that area, by using USA Trains trucks, where I actually lower the bolster within the truck side frame. And they have, of course, the KD center set couplers. And there are AML brand PS 4750, Pullman standard, that is 4750 cubic foot hopper cars here. They're a little more modern. And of course there's the 60-foot box car. It's a USA Trains box car, where I also put KD center set 906 type couplers that are extended here to make it look realistic. And of course the USA Trains caboose, which I also mounted KD 907s, but I didn't put a glue block under it. I basically used the tang off the truck and mounted the tang to the under frame of the car, and that way you can look at the catwalk here and not see a bulky glue block there like prior art methods of mounting these have been. So right now the train is headed to my outdoor layout. I'll speed it up here. Here it's coming over the reinforced LGB bridge. Again, there's a total of 18 cars, including the caboose. And it's traversing the first loop here. These engines are fairly light. They're about 7.9 pounds, and I removed the traction tire wheels and replaced them with solid wheels. And they don't have the advantage of the traction of the traction tires, but on the other hand, they won't have excessive loading on the motors, causing them for possible damage under high load conditions. And these grades here vary between roughly 2% to 2.5–3% in some areas. So the overall average is about 2.2% on this outdoor layout. And here it's coming over the second loop, my double loop. of course I'll have to back it down here since I have yet to add the rest of the trackage here to the outdoors. You can hear the coupler slack being taken out. Again, these USA Trains engines, they measure 7.9 pounds on the scale, and they also have, I put series 1 ohm resistors in series with each motor, and that's to, like George Schreier pointed out, to help minimize the potential for pitting of the wheels, since these motors seem to draw a very high inrush current when they're started up, or if they should be operated on pulse width modulation mode, or PW, pulse width control as Aristo calls it. So that's a precaution to save the wheels and also save the motors. And the resistors slowed down the speed of the loco very minimally. It's almost a difference between two different locos from a given manufacturing production run of the same loco type. Didn't slow it down, didn't change it appreciably very much. Because these locos are fairly lightweight and they don't have the advantage of the traction tires, I prefer to MU more locos again for saving the hardware rather than, or perhaps risking damage to the hardware, rather than to rely on the supposed advantage of traction tires. But by replacing the traction tires, you get a bonus of 2 more pickups, the wheel contact for rail power, which I use track power here. And I also kept the sliders, and they seem to work fine on my layout here. So the more pickup points include the slider and the wheels that are all metal, that don't have the traction tires on. They make contact to the rails and therefore help distribute the current at any given patch point to again minimize wheel pitting issues that George Schreier wrote about on his website. Now, compared to the Aristo GP40, the GP40, when weighted 2 more pounds, in that case it's around 11.5 pounds. I have several GP40s, and I've also put stainless steel wheels. The wheels on the GP38s are unrealistically small. They're in diameter. That's why I had to raise the locos up to be a little more prototypical when I decided to put the proper KD couplers on them and maintain the proper coupler to railhead height. So you want to take care of issues of whether it be the loco or the car, compare it to an actual prototype loco to see how much you should lower it, and that's an opportune time in which to kill 2 birds with 1 stone, so to speak, and get everything proper. But the Aristo GP40 will outpull these things, all things being equal, since they have ball bearing trucks and you can weight them more. The axles are on ball bearings, and so the additional weight over these USA Trains ones without the traction tires, the GP40s will pull a bigger load. But still, these are very nice locos. Now here's another run of the Rock Island all blue train in the blue scheme. And again, all these locos and cars have body mounted KD center set couplers, all body mounted. slow it down here near the end of the track. Now I have to back it down the hill. Today is June 23rd, 2013. It's supposed to be summer. It's the second day, or third day following third summer day. And yet it's overcast and it's starting to sprinkle a little bit, so the tracks are getting a little bit moisture on them, and they're all stainless steel tracks. So the local wheels will tend to slip a bit because of that. On the first run, it wasn't sprinkling, and it's not really much of a sprinkle, but it's still enough moisture in the air here. The forecast is for rain tonight and tomorrow. Unusual for our summer. There's the train backing onto the LGB bridge here, going to the underhouse portion of the layout.